Hello calculus, we're up to, this is an old board here, we're up to watching this after Thursday's class on the 29th. So today our calc video will be putting together some things from class yesterday. Hopefully from the night before you did a list of limits as h approaches 0 of different expressions like x, x squared, x cubed, x to the fourth. What else did you do? 1 over x and square root of x, I think. So at the end of that who struck, you were asked to look for some patterns. So maybe we can find a quicker way to get the derivatives. From that, hopefully you notice that there is something that exists called the power rule. And that says the derivative, remember d over dx, d dx is just a symbol for the derivative of x raised to the n. So we have x raised to some number n. Then its derivative is n times x, and then the exponent reduces by 1. So basically the numerical exponent runs down in front and then it's reduced by 1. And it seemed to work in all of those examples that we tried the last 2 nights. I guess it was last night from the perspective of when you're watching this. Alright, so we have called that the power rule because it's dealing with an expression that is raised to a given power. And that number can be a fraction, it can be a negative number, and so forth. Does it fit for a constant? Does the power rule work? Suppose we're trying to take the derivative of a constant. Well, I know what I expect the answer to be, because a constant, if we have y equals some number c, such as 3, we have a straight line. Y equals 3 is a horizontal line at 3. So therefore, we're expecting a derivative, which is the slope at a given point. Everywhere at every point there, the slope is the same. The slope, there is no slope, so it's 0. If you're trying to ski on that, you'd have some issues. So the slope is 0. So we're expecting the derivative of a constant function to be 0. Does it follow the power rule? Well, we can write c as x to what exponent? 0. So that would be anything to the 0 is 1 times c. And when we do that, we know that the derivative is the 0 runs down in front, and this decreases by 1, and we get c equals 0 over x. 0, x to the minus 1 creates x in the denominator. So we have 0 times c, which is 0. So it does follow the power rule if you want to force the issue. But let's be aware then that the derivative with respect to x of any constant is always 0. Alright, and this is sort of how the thinking goes. So let's look at another one. How about y equals, I want the slope of y equals x to the 7th, that curve, at x equals 1. I want to do it at x equals 0 and x equals negative 1. So I'm looking for 3 different answers. What's the slope of this curve when x is 1, 0, and minus 1? Always keep in mind what the question is asking before you start throwing in formulas and patterns. Y equals x to the 7th. It's going to be some sort of something like y equals x to the 3rd. And we learned all the odd functions act somewhat like their parent function, y equals x to the 3rd. It'd probably be a pretty thin function. because when you put in like a 2 to the 7th is a very large number. So what's the slope of this at x equals 1? To figure that out, whenever you see slope, you think derivative. So let's find the derivative the quick way, y equals x to the 7th. So I'm going to go y equals, the 7 runs down in front and reduces by 1. So that is the derivative. I'll indicate it with y prime. So I want to evaluate that expression at x equals 1. I can indicate it with a line and a little 1 there. That tells the reader that I'm going to substitute 1 into that expression. And I'm going to get 7 times 1 to the 6th, which is 7 times 1, or 7. Does that make sense? If we come out 1 on this function and hit the graph, we come out 1 and hit the graph, does that look like it has a very steep slope of 7? I think so. So what are we expecting when x is not 1 but 0? So we're going to change this to a 0. 7 times 0 raised to the 6th, and we're going to get 0. Does that make sense? It does look like there's a tangent line there that's horizontal, and at -1, we still get the same derivative, but we're plugging in a -1. What is -1 to the 6th? That is going to be a positive 1, so we're also going to get 7. Let's see if it makes sense on our drawing. At -1, we go down and hit this graph, draw a tangent. Still a very steep slope. Positive 7 could possibly be it. And it is. All right. So if I asked you to find the slope of a function at a given point, always start with the derivative and plug in the value for x to find the specific slope at that point. So do you see a derivative is a function? There's another, you have to start with a function. The derivative is another function that tells you the slope at every point. All you have to do is plug in the value of interest. All right, the next topic that we want to do today is looking at an expression where, or this kind of question. Just like you're asked to find the slope at different points, sometimes you're asked to find the, you're going to be asked to find the equation of the tangent line of a given function, say of f of x equals x squared, and we'll do that where x equals -2. So again, keep in mind what we're asking. So we have y equals x squared is our smiler, and they're looking for the tangent line at -2 for x. So -2 brings me here. On the graph, I draw a tangent line, and this, we want not only the slope there, we want to take it, upgrade it to the actual equation. So the straight line always has an equation, y equals mx plus b, and we're going to leave that be our guide. So what we need to know is the m and the b, and we have the equation for this tangent line. So m is slope. So what is the slope of the tangent line? Well, we know that at this point, the slope is the same as the derivative at that point. We evaluated at -2. So let's find the derivative. The 2 runs down in front and reduces by 1, and we're going to evaluate that derivative at the point -2. When I put in a -2 into the derivative, I get 2 times -2 equals -4. Does that make sense? Does this graph look like it has a slope of -4? It is negative direction, so yes, I think that makes sense. So with that, let's go ahead and fill in y equals m, in this case is -4, and now we need the b. To get the b, we just for a moment, we're going to find one x and one y on the graph, and then plug it in, find b. Then we're going to go back to our x and y expression, but we're going to substitute our value for b. So what is one point that we know for sure is on this graph? Well, we know that -2 is on this graph. When I say this graph, I don't mean this graph. It's this one I'm looking for. What's one point that I'm sure is on this tangent line? Well, we know the question is asking for the tangent at -2. So right here we have an x value of -2. How can we find the y value? Well, at this point is not only on this tangent line, it's also on the curved line. It's also on the parabola. So we can put -2 into our function. That x looks a little wiggy. We can put our x value, -2, into our function and find our y value, because f of x means y. So we know at every point on this parabola, y equals x squared, and that includes at -2. So when we do that, we get y equals 4. So we know this point is 2 back and 4 up. That point is also on our tangent line, so I'm going to borrow the 4 for y and the -2 for x and solve for b. So what do I get? 4 plus 8 equals b. Move the 8 over by subtraction, and I get a -4 for b. As promised, I'm going to go back up to this form and replace b with the value found, -4. This is the answer to the whole problem. It's the equation of the tangent line of this graph, y equals x squared when x equals -2. All right. So you'll be practicing some of those tomorrow. And before I leave, I do want to point out two other, I guess we would say, two other expressions that will come out of this one. So I'm going to give you a more complex expression and find its derivative. So you'll see in the next part. So let me shut this down and come back on part 2.